Right, 2021, question 6. So, had a theory at the start. Give two commercial sources of hydrogen gas. So, where can hydrogen gas be produced? So, the ones there you'd be thinking of there, I always think of dehydrocyclization. So, it's one of the ways of making a low octane number and a high octane number. And one of the products there is hydrogen gas given off. Another one there is steam reforming of natural gas. You do need to know your equations in that. There's two, specifically one anyway. CH4 is your natural gas, and steam, H2O, producing hydrogen and carbon monoxide. Steam reforming of natural gas. And you could also mention there electrolysis of water, which is very expensive. Two main advantages of using hydrogen gas as a fuel. So hydrogen gas, you could say the only pollutant is water. It's got a high kilogram calorific value. It's a high octane number, and so on. Right, what are the two main hydrocarbon components? So hydrocarbons, remember, consist of carbon and hydrogen only bonded together covalently. And there's three families that we need to learn about in our course. We had to study the alkanes, alkenes, alkynes. And we would have studied them in the chapter on fuels here. So the two major components of LPG, we're thinking there, propane, which is C3H8, and butane, C4H10. And you can see even when I listed the formulas there, C3H8 to C4H10, one of your things of your functional group is that they differ between CH2. So if I add on CH2 each time, that works out. With the aid of a diagram, I'm not going to do that. So look at your book. So it's a simple diagram. Explain how it's fractionally distilled. Now I'll waffle through how it's distilled at the same time. So distillation or fractional distillation separates crude oil on the basis of their relative molecular masses and on their boiling point. So that's the two key components there. How does it separate it? On the relative molecular masses and according to similar boiling points. So longer chain hydrocarbons with the greater relative molecular mass come off lower down or further down in the column at higher temperatures, whereas your shorter chain hydrocarbons with smaller relative molecular mass come up or come out further up in the column or boil off further out in the column at lower temperatures because they've got weaker intermolecular forces. Link that into your van der Waals forces. All these hydrocarbons are non-polar, insoluble in water. So just going back over that then, so the hot crude oil introduced into the base of the column, your short chain hydrocarbons with low relative molecular masses come off higher up in the column at lower temperatures, whereas your long chain hydrocarbons with greater relative molecular mass come off further down the column at higher temperatures. Showing your diagram where the refinery gas and your gas oil fractions, that's just, you need to know the order in which the refinery gas, like gasoline, naphtha, kerosene, then you've got your gas oil, your residue and so on. So you do need to know the order in which they appear. So as long as you put your refinery gas near the top of the column and your gas oil further down in the column, you'll be okay there. So 18 marks, not the nicest, but that has appeared a few times. So your diagram, it's nothing swanky. Let's say something like that. Your crude oil, your different fractions. I don't know where that went there now, but something like that. And your hot crude oil going in the bottom. And your, the greater the temperature, higher the temperature is further down. Jeez. And the lower the temperature, further up. That's real rough. What is the purpose of adding mercaptans to natural gas or LPG? So mercaptans, they're very smelly organic sulfur compounds added, and the reason they're so that leaks can be detected. So it's a safety measure. So if you can smell leaks, if you left your gas on, you can smell it. And then my old favourite, I love these calculations, I live for them. The heat of combustion of ethane thiol, according to the following balanced equation, is that. So once I see that there, I'm writing down my formula straight away. Heat of combustion, sum of a heater formation of your products minus your reactants. So your products go first and then your reactants. Now this is the second type of the calculation where they give you the heat of combustion. The heat of combustion is 1867. So we're asked to work out the heat of formation of one of these substances. Minus 1867.5. Remember, the minus just means it's an exothermic reaction. This heat's been given out. Use this heat of reaction and the heat of formation of carbon dioxide, water and sulfur dioxide to calculate the heat of formation of ethane thiol. There we go. So my products, 2 carbon dioxides. This thing means the sum of. So 2 by, what's my carbon dioxide? Minus 393.5. plus water. There's 3 waters. I can see that from the number in front of it. 3 by minus 285.8. And then you've got a sulfur dioxide, 1 by, what's my sulfur dioxide, minus 296.8. And then my products, I've only got their ethane thiol, so we'll just call it minus X. You can call it C2H5SH if you wish. So we tidy that all up. Minus 1867.5 is equal to, big dirty brackets, work out your products first. 2 by minus 393.5 gives you minus 787. Minus, my pen battery must be dying here, minus 285.8 by 3 gets you minus 857.4 minus 296.8. Tidy that all up inside the brackets. Oh, minus 1941.2 minus X. Now I want to keep my X positive, so I'm going to bring her over there and bring that over there. So I've got X is equal to minus 1941.2 plus 1867.5, comes across the equals, changes its sign, and the Bosch will get an answer now of minus 73.7 kilojoules per mole. So a lovely calculation there, 15 marks out of 50, 30% of the question with your usual kind of wee things, mercaptans, how hydrogen's produced, and your fractional distillation. To me, that was the tough one there.